And welcome all, this is Mr. Callan here to help you with March 24th, lesson 9 3D. We're going to be adding, subtracting rational expressions with some notes pages. So get on that notes page out. Again, focusing on where we've been, adding, subtracting numeric fractions, where we're heading now. And of course, we got to be looking at those common denominators, right? You will hear me use that word least common denominator or least common multiple. Always, always, always try to simplify. Look for a factor to multiply or divide by. Sum is a fancy word for saying add, and difference for subtract. If you need, get your notebook out. We're going to be adding some notes into our notes page right in front of us, as well as into your notebook. All right, so let's pause for a second and look at the first part of this notes. We need to find the least common multiple for each pair of polynomials. Now, basically what we're heading to is if you had to add 2/3 and 3/9, you're going to want to find both a least common denominator. Now, surely if you multiply, you're going to get 27, and yes, that works, but it's not the denominator that is least. In fact, many of you would have noticed we simply need 9 and 9. All right, so that's numeric. What are we going to do for algebraic? Just picture these in the denominator of some fraction, or picture it just with 8s and 12s. Now again, you could multiply and get 96, but surely there's something smaller. And in this case, both of these will very nicely go into 24. But it doesn't just have numbers in this monomials. There are variables as well. Well, in this case, as some of you already noticed, we have x to the 4th and x to the 2nd, and they both share 2 of them, but this guy's got some extra. In other words, x to the 4th will be the least multiple that is in common for x to the 4th and x to the 2nd. The other way to think about that is, what if it was just the x's? And you could see very quickly that you could change both of those into x to the 4ths. So in this case, the least common multiple of 8x to the 4th and 12x squared is going to be 24x to the 4th. And later on, we're going to say, okay, what would we have to multiply by numerator and denominator to get that 24x to the 4th? What would we have to multiply this numerator and being fair to the denominator to get 24? Okay, taking a look at number 2 now, you can see that they both share an x to the 5th here. Just kind of imagine a fraction on top of this. They both share an x minus 5 as a factor. They both share an x, but one of them has 2 of them, one of them has 1 of them. So the least common multiple of that piece is going to be x to the 2nd. Now look at 2 and 4, where many of you are going to say, oh, Mr. Callan, I already got that. Both of those would go very nicely in a 4. Could you multiply and make it larger? Yeah, I suppose some students might have had 8x cubed. But why bother if we're looking for the least in common? So both of these polynomials can be multiplied by something in order to get the least common multiple of 4x squared times x minus 5. Notice in this case, it would actually be times 1. You don't actually have to change anything over there. But on the other side, you're going to need to multiply by something. We'll get to that when we get to adding and subtracting. All right, now can I ask you to pause? I want you to factor all of number 3 and 4 out, and then come on back when you're ready. Notice number 3, I warned you a while ago I was going to blitz you with pulling out monomials from this. And over here, there is nothing that can be pulled out, but both of those are perfect squares, which means if we make one a positive and one a negative, we're going to have x squared minus 36. Okay, so if these were a denominator, what could we find that is shared in common? You notice the x minus 6 is in common, but we will also need an x plus 6, and we will also need a 2x. So the least common multiple of 2x squared and minus 12x and x squared minus 36 is going to be 2x times x minus 6 times x plus 6. Again, forgive me if you already did this. If you factor out a 2 from the first trinomial, and you factor out both a 3 and an x from the second trinomial, now I'm going to continue factoring these. And while I'm at it, let's go with the second one where x minus 4 and x plus 2 will be equivalent. If you need, go off to the side, do your box, do your x, and you'll see that those are equivalent. All right, over on the right, we're going to have an x plus a 3 and an x plus a 2. That will give us a sum of 5x and a product of 6. Okay, again, I will underline everything they have in common. They both have an x plus 2, so don't forget that x plus 2. Not only that, we're going to need an x plus 3. We're going to need a 2. We're going to need a 3x. Goodness gracious. And we're going to need an x minus 4. Now, I don't know if I'll give you anything this challenging on the quiz, but if you put all that together, you would have the product of 6x times x plus 3 times x plus 2 times x minus 4. If you can find that, then you're going to be good with anything that we have with finding least common multiples. But I'm going to put a big old star here because I think 4 is supposed to be one of the more challenging problems. If you need, pause, go back, rewatch this while we continue on with actually using that least common multiple to add, writing the answer in simplest form, and yes, we are supposed to state restrictions to the domain. Now, I would argue that the first problem, pretty quick and simple. They already have a common denominator. So really all you have to do is add the two numerators. Can anything pull out of every single term? No sir, no ma'am. And let me just go ahead and pause and state, hey, don't forget, negative 4 is going to be a restriction to that domain. You cannot substitute a negative 4 and make this a reasonable defined statement. Now looking over here where things get a little harder, in fact what you could do right now is you could go through this whole thing and try to find all those common denominators. But I'm just going to go through it one by one, piece by piece. If you would like, you're welcome to do that. Pause the video and come on back when you're ready. But I noticed that both of these can turn into something who have denominators of 8. Now the nice part is the first fraction does not need to change. The second one will. What will we need to multiply by? And in this case, we'll have to multiply both numerator and denominator by 4. Now that we have that common denominator, I'm not going to write an equal sign, but it's okay if you do. We're going to have x minus 3 plus 4x. And yes, you have some like terms that we can combine. So we get 5x minus 3 all over 8. Does anything subtract, divide, reduce out of that? Nope. And are there any denominators, are there any x values that it cannot be? Well, guess what? There's no x in the denominator. There's no x that would blow this problem up. Let's continue on to problem 7. Look how 7 and 8 are similar. Look at how they're different. Firstly, we can notice that, well, there is no number. Let me go to the right here. No, I'm just going to keep going up and down. There is no number that is shared in common. There's no factor that is shared in common. So we're going to need a 2x, and we're going to need an x plus 3. Let me write that in a different way. We're going to need, let's picture it, shall we? Begin with the end in mind. We're going to need a 2x and an x plus 3 down in the denominator. So for the first one, we're going to need to multiply both numerator and denominator by the sum of x and 3. That's going to give us 5x and 15. For the second one, we're going to need to multiply both numerator and denominator by 2x. That's going to give us 2x squared. And now, if we rewrite this in standard form, there are no like terms, but we're going to put the x squared first, the x to the first second, the 15 third, all over 2x times x plus 3. We're going to ask, can anything divide out of each and every term? I almost said x. This has an x, this has an x, this has an x, but that does not. So we can't reduce by x, we can't reduce by 2, we can't reduce by 5. In other words, there is nothing that will reduce into all of those. While this is simplest form, I do want to pause and say, hey, don't forget, x cannot be 0, nor can x be negative 3. There are restrictions to this domain. Let's keep on keeping on, ladies and gents. First thing I'm going to do is I'm going to factor the right problem. And notice that we have a 2 and an x that can be pulled out of this. Let me just make sure I'm doing this right. 2x times x, still 2x squared. 2x times negative 2, still negative 4. Good. Oh, and look at there. They both have, speaking of disappearing ink, they both have an x minus 2. So I'm going to write that we need an x minus 2 in the denominator, but we're also going to need a 2x. So let's multiply this first term. Let's stick to purple first, huh? We're going to need to multiply this first by 2x over 2x in order to get 2x times x minus 2. Oh, guess what? We have everything we need, ladies and gents. There is nothing needed for that right piece. So I'm simply going to write plus 4. Oh boy, in this case we actually can reduce both numerator and denominator by 2. And we're going to get x squared plus 2 all divided by a single x multiplied by that factor. And restrictions to the domain, once again we find that x cannot be 0. That would make an undefined quantity, but so would positive 2. And there's our final answer for problem number 8. Getting a little more complicated. For number 9, I noticed that nothing will cross-reduce. Nothing will factor out. I don't know why I said cross-reduce. That's only for subtraction. So I'm going to begin with the end in mind and say, okay, I need a 3x minus 1, plus 1, I need an x minus 5. Begin with the end in mind. So in order to make this happen, let's multiply the first quantity by 3x plus 1 over 3x plus 1. We're going to have to multiply the second quantity by x minus 5 and x minus 5. Now let's go ahead and distribute the 2x times 3x, 6x squared, and 2x times 1. Let's distribute the 4 times x and the 4 times negative 5. Whoops, I missed my x there. Are there any like terms? There sure are. I'm going to combine the x terms, 6x squared plus 6x minus 20, all divided by the product of 3x plus 1 and x minus 5. Now I'm going to leave it like that, but I would like to point out that x cannot be equal to negative 1/3, nor can x be equal to 5. Last but not least, let's do this one more time. Uh-oh, I'm going to rewrite this in factored form, noticing that x squared minus 8x minus 15 is equivalent to x minus 5 and x minus 3. Now, I happen to think this one's a little challenging. You might disagree. But can I point out, please, that if we multiply both the numerator and the denominator by negative 1, look at what we end up getting. We end up getting negative 1 times 5 is negative 5, and negative 1 times x is negative x is positive x. So we see we have a shared factor in common here, that we can actually find an x minus 5 in both. So beware, in other words, if you have two numbers, two quantities that are the exact opposites of each other, that you can take a negative 1, excuse me while I finish that up, this should be negative x then on top. And you can multiply both the numerator and denominator by that negative x, so that now we can see the two quantities, the two factors, oh I did it again. The two factors are equivalent with the x minus 5. Okay, that one might take a little bit of rewinding. Do that again. So both of these share an x minus 5 now, and we're also going to need an x minus 3. Hey, good news. Nothing's got to change on the right side. It is only the left that we're going to have to multiply by something in order to get our new common denominator, right? So I have the x minus 5, we need the x minus 3, and anything we do to the denominator, let's be fair to the numerator. Distributing negative x times x, negative x squared, negative x times negative 3, positive 3x. And we are going to add 3 more x's, in which we find the opposite are a negative x squared plus 6x all over x minus 5 and x minus 3. Now I know many of you in the past, yesterday in activity, you would actually distribute this out. But I'm going to choose not to because those quantities right now can help me pick my exclusions. See, in this case, x cannot be 5, nor can x be positive 3. So our final answer here, negative x squared plus 6x all over the product of x minus 5 and x minus 3. Now pause for a second. I want you to answer these two questions. Come on back when you're ready. I hope at some point in time you talk about needing common denominators. And honestly, both of those problems already have common denominators. So you can go ahead and add the numerators together. When it comes to a difference, which of course is going to mean subtraction, how is it similar to finding this? Well, for this, we're going to need to get common denominators as well. But in this case, since they were different, you need to multiply numerator and numerator, denominator and denominator. In other words, make it equivalent, be fair, but now that you have common denominators, you can subtract. Folks, that is exactly what we're going to do with this. We're going to have to find it so that we find those common denominators, x plus 2, x minus 5, x plus 2, x minus 5. But anything you multiply by the denominator, you have to be fair to the numerator. So again, you're going to need common denominators, but if you have to multiply first to find equivalent fractions with these common denominators, then you're going to have to do that. So that leads into subtraction. This one's going to be a little tougher, a little longer. We are going to be asked to subtract, writing the answer in simplest form, stating any restrictions to the domain. So as weird as this is, I'm going to go through every problem. I'm going to look for anything that can be factored. I would encourage you to do the same. Pause, factor the denominators, and come on back when you're ready. Now, if this one looks awfully fishy to you, what I'm going to do here is exactly what we did on the front side. Let me do it in red so you can pause the video and go on back and look for that red if you need. I'm going to go ahead and multiply this guy by negative 1 over negative 1. And the reason for that is, now I'm going to have, sure, negative 2x and negative 7, but I'm going to have a positive x squared and a negative 4. Mr. Callan, you don't even have to factor those now that I think about it. If I saw that, forget that. They already have a common denominator. So the most important part here is multiply numerator and denominator by negative 1 over negative 1. And now you can see that those two denominators will match perfectly. Let's keep on going with the factoring, so I'll come back to that problem. Number 15, we can pull a 2 and an x out of this binomial. Nothing out of here. Number 16, we have the difference of two squares. X times x is x squared. 2 times 2, as long as one is positive and one is negative, we're going to be okay. As for this guy, this one might take the box off to the side if you need. We're going to have an x plus 5 and an x minus 2. All right, now that everything is factored in this page, folks, now I'm going to go ahead and we're going to find those common denominators. We're going to subtract, we're going to simplify, we're going to find restrictions. These already have a common denominator. So just like number 14, we're going to be able to dive directly into number 11 and come up with the answer immediately. 7 x's take away 7, all split up into x minus 1. Whoa, check this out. 7 times x minus 1 over x minus 1. This actually reduces perfectly to 7. I didn't even notice that when I was doing this problem. However, I do need to point out it's only going to work as long as x is negative 1, is a positive 1 is excluded from there. Wow, I didn't even notice that when I did that problem. Let's keep on going. Number 12, I'm going to sneak in a little 1 right here, and I'm going to point out that both of these could have a common denominator. Well, 1 and 3 can both go into 3. X squared and x cubed can both be changed to x cubed. Noticing this guy does not need to change. I mean, you could have put times 1, but that doesn't change anything. So let's get some purple out and let's multiply this guy. What are we going to have to multiply both numerator and denominator? Well, I'm going to need a 3, and I'm going to need an additional x. Now 3x times 1x squared gives us the 3x cubed that we need. Let's go with that numerator as well. 3x times 5 is 15x. Let's go ahead and subtract. 15 minus 2 is 13 over 3x squared. Nothing divides out, nothing reduces. But let's make sure that we disclude 0. If you put 0 in, you're going to have a number 13 divided by 0, and that's impossible. So 0 is going to be excluded here. If you notice I'm going too fast, go ahead and pause the video, write down what you need, rewind what you need, come on back when you're ready. In this case, we have two quantities. We have 5 over x plus 2. We have 2 over x. Nothing factors, so if I were to envision where I'm heading, I need both an x and an x plus 2. In order to get that, this first one, if I multiply everything by x over x, then I'm going to get x times x plus 2 as the denominator. I'm going to get 5x in the numerator. Over here, I'm going to multiply everything times x plus 2. So in the denominator, we'll have x times x plus 2. In the numerator, let's distribute. We end up with 2 times x and 2 times 4. However, please make sure you're being careful for that negative symbol. We are subtracting 2x and we're subtracting a positive 4. Therefore, our answer, 5x take away 2x, is going to be 3x. And then we're taking away 4. All divided by the product of x and x plus 2. Nothing simplifies, nothing reduces. Let's make sure to exclude 0. And let's make sure to exclude negative 2. Number 14 was quite nice. After we manipulated one of the denominators, they both now say x squared minus 4. So in fact, all we have to do is subtract the numerators. We need a 3x plus 1, and we're subtracting now, don't forget, we had to change this guy, we're subtracting negative 2x and a negative 7. Now, mind you, we are subtracting both of those, which is going to change that to addition, and is going to change that to addition as well. So we end up with, sorry for my messy writing here, let me scoot this up a little bit, shrink it down. We end up with a denominator of x squared minus 4. We have 3x minus negative 2x. 3x plus 2x is 5x. We have positive 1 minus negative 7. Positive 1, positive 7 is positive 8. With the exclusions, okay, so maybe I should have left it in factored form, but you guys can see it up here, can't you? We cannot use 2. 2 squared is 4. 4 minus 4 is 0. Nor can we use negative 2. Negative 2 times negative 2 is also positive 4. Which would make an undefined quantity. All right, getting into the tougher ones now to wrap up. Where are we going? Begin with the end in mind. Both of these have an x plus 3, don't they? But we further need a 2x. Hey, good news. We got everything we need over on the left side. There is nothing we need to change to the numerator because we already have 2x times x plus 3 in the denominator. However, over on the right, we're going to need to multiply denominator by 2x. Well, then we better be fair to the numerator. So 3 sets of 2x is going to be 6x. Don't forget, we are subtracting that quantity from 4. Got to be honest, some people are going to leave it as that. I'm going to rewrite it in standard form, negative 6x and a positive 4 over the product of 2x and x plus 3. Either way, you're going to see exclusions. X cannot equal 0 and x cannot equal negative 3. All right, time for the big fella. Try to picture, what do they have in common? Well, they both have an x minus 2, so we're going to need a factor of x minus 2. We're going to need a factor of x plus 5. We have that on the right. We're going to need a factor of x plus 2. You have that on the left. Holy cow, ladies and gents, we got a lot going on. So we have to multiply x over something times, can I move this? Let's find out. Give ourselves a little more space. There we go. All right, so what do we need to multiply that left side by? What are we missing? What is the missing factor that we need? Oh, well, we got this, we just need the x plus 5. So let's multiply both numerator and denominator by x plus 5, leaving us with x squared and 5x. Don't forget, we're going to be subtracting something, but what is it that we're subtracting? Well, over here, we have the x minus 2 and the x plus 5. We still need the x plus 2. So I'm going to go ahead and multiply numerator and denominator by the sum of x and 2. Leaving us with 3x and 6 to subtract. So, remember please, we have a very large denominator, the product of 3 different factors, x plus 2, x minus 2, and x plus 5. Now we have x squared plus 5x minus 3x is going to be plus 2x. Plus 5, all we have is a minus 6 at the end. Huh. And I think we're finished. I'd like to tell you that that one factors nicely, but I'm not sure it does. Meanwhile, 3 different exclusions at this time, folks. In order from least to greatest, I see negative 5 would blow it up, I see negative 2 would blow it up, and so would positive 2. Now, pause if you need. Write down first step to computing anything rational, as well as restrictions. Come on back when you're ready. Now, some of you might have said common denominator, but you don't need common denominators for multiply divide. You only cross cancel with multiply. You only flip the division into multiplying by its reciprocal for divide. But no matter what, for any rational expression, it's definitely going to help us out to factor first. Meanwhile, for the restrictions, you're looking in the denominator. You're looking for any value that would blow it up. So for instance, if we had that big one, that big fellow that we just did, what is the possibility that you would have 0? Because no matter what you'd have in the numerator, anything times 0 is going to mess things up, right? So we used to once upon a time flip it up like this. Well, if x plus 2 is the 0 portion and we subtract 2 from both sides, you can see negative 2 is going to be no good. If x minus 2 is the 0 portion and we add 2 to both sides, you're going to see that positive 2 is the no-no. But what if the last factor is the 0 part? What if this is the 0 part? Well, in order for that to be the case, then x would be negative 5. So the key is to look at the denominator, imagine that it is equal to 0 as an equation. What quantity or quantities would create 0 in the denominator, which would come up with any number divided by 0 is, well, non-existent. It doesn't work. Folks, that's all I got. Remember that you should be heading back to your notes, put a few extra things in your notebook. Homework is going to be due tomorrow, so take care of that, please. And as always, if you have any questions, you can email me or let me know in class the next day. Take care, do well. Let's go. See you, folks.